Do go ahead and get started. So welcome to the Category 3 and 6 workshop. Today we're going to go over 5 different events. I'm going to go over Chem Lab, Alice will go over forensics, I'll do Write It, Do It, Maudie is going to go over Codebusters, and Alice will do experimental design. Also note, today we've combined both categories 3 and 6 for our presentation, but on tryouts we are not going to combine the categories. This also does not mean that categories 3 and category 6 are similar in any way. They really aren't, and they have their differences, and we'll note that during the presentation. We've only combined them since category 3 has 2 events and 6 has 3, so it makes sense to combine them. Also, throughout the presentation, if you have any questions, feel free to text them on the chat on the bottom right, and we'll address them at the end of the presentation. Okay. We're going to go ahead and start with Chem Lab. Okay, so what is Chem Lab? So Chem Lab, just as assumed by the title, is a chemistry-oriented event. And in Chem Lab, you do 2 things at the tournament. First, you complete 1 or more labs or tasks. And once you complete these tasks or labs, you answer questions about them at the tournament. And these labs are kind of like the ones you would do at school. If you've taken chemistry already, you know that we've done a lot of labs this year, and Chem Lab would have this, the same type of labs just at the tournament. So it shouldn't be anything new. Secondly, you also answer questions about chemistry, and every year there is a specific theme or a specific topic for Chem Lab that is tested upon. And for those of you who have attended our introduction meeting in July, you know that the topics are going to stay the same this year for every event as last year because of COVID-19. So this year for Chem Lab, that means that the topic is still going to be aqueous solutions and acids and bases. So on this portion of the test, you will be answering questions just about aqueous solutions and acids and bases. Also to note about Chem Lab, you are allowed a cheat sheet, just like in anatomy or physiology or designer genes. Chem Lab, you are allowed a cheat sheet. And a really important thing to know about Chem Lab is that you will need to have safety equipment, and the rule book lists all the types of equipment you're going to need to bring, like goggles or aprons, maybe gloves. And so on the tryouts test, expect you to see some questions about the different types of safety equipment you're going to need for Chem Lab. Okay, so what do you need to know? Okay, so just like I said before, the theme this year is aqueous solutions and acids and bases, and that's exactly what you're going to need to know for Chem Lab this year. However, this is a very, very broad topic, and we understand that. There's a lot to know about aqueous solutions. There's a lot to know about acids and bases. You have to know anything and everything about the equations you write for acids and bases, their properties, how to calculate aqueous solutions. There's a lot of stuff to know, and we get that. So for tryouts, we're not going to expect you to study and learn everything about this topic. That's too much. And you only have 4 weeks, and we know you're also studying other events. So we're not going to test you on everything. Instead, we've broken it down for you as seen in our resource packet. And right here, I have listed the bullet points on the packet that you're going to need to know for tryouts. Starting off with the symbols and charges for the following acids and bases. You're actually going to need to know this in Chem Lab if you do pursue in it later this year. And for tryouts, we're going to need them to know them as well. The symbols and charges for nitrate, carbonate, phosphate, acetate, sulfate, ammonium, bicarbonate, and hydroxide. These are actually pretty easy to study for, though. If you just search up some Quizlets online, I'm sure there are going to be plenty. All you have to do is just go through those Quizlets. It should take like maximum 10 minutes. It's really not that hard. We're also going to, actually, Chem Lab asks you for the basics, to know the basic properties and uses of acids and bases. Again, we've broken it down. You only need to know the basic properties of hydrogen chloride and magnesium hydroxide. And we provided readings on that in the packet. And we need you to also have a foundation in acids and bases, so we know whether you know what you're talking about or not when it comes to chemistry. And so we need to know the particular properties of acids and bases, like whether an acid is sour or base is bitter, you know, their chemical compositions, stuff like that. We need to know what indicators are and what they're used for. Indicators like methyl red, and you know how you use them when it comes to acids and bases and pH. You also need to know how to match conjugates, which are in the notes in the packet, what monoprotic, diprotic, and triprotic acids are, and pH and pOH, and how to calculate them. You are also required to know acids and base reactions for Chem Lab, and there are all sorts of reactions you need to know, but we only need you guys to know metals and neutralizations. That's it. Calculations, again, there are a lot to know. We're only asking you for percent composition for tryouts. And then Chem Lab also requires principles, properties, terms, and definitions concerning aqueous solutions. Again, that's really broad. So we've narrowed it down to the vocabulary words I've listed in the packet, the properties of aqueous solutions of both ionic and molecular compounds, what solubility is, and there's a graph on the packet and how, you know, that graph characterizes solubility. Solution situations and what affects solubility, like agitation or temperature increase and decrease. And then finally, you have to calculate solution concentration as you're given the solute and solvent. And again, I provided notes for that. And one thing I really want to say about Chem Lab. Chem Lab is a heavy, actually solely based on chemistry. It is solely based on chemistry. So if you want to do Chem Lab after trials, if this is like an event you would want to do, you need to make sure you have some chemistry background. If you have not taken pre-AP chemistry at the very least, or AP Chem, then you're going to need to have that inner drive at least to be able to self-study all of chemistry, and because you're gonna have a hard time if you don't. For those of you who've taken chemistry, you know all of this is actually kind of a review. You've learned all this this year, and you know that there's a lot to know about acids and bases and aqueous solutions, and it requires a lot of background stuff. So and also on the resource packet, if you've seen it already, a lot of the notes are from my pre-AP chemistry notes from this year. So again, that kind of proves what I'm trying to say, that you do need chemistry background. So keep that in mind as you choose your events. Okay, so next up, I have some examples of some questions you might see both in Chem Lab and on the tryouts test. The two questions above the line have to do with acids and bases. The two questions below have to do with aqueous solutions. So I'm going to run through them real quick. So the first one, number 5, fill in the table below. So this is an example of like a free response question you would get on the test, where you have to actually write in the questions. It's not multiple choice. And this is actually a pretty simple question. It's just asking you to match the definitions of acids and bases with Arrhenius, Bronsted, Lowry, and Lewis models. So that would be an example of a free response question you could see. The second one is in the following reaction, what does water act as? So the second question is more of like it's more of an application question. So you have to apply your knowledge of Arrhenius, Bronsted, Lowry, and Lewis into a question. So it's not as straightforward. And if you look at the equation, you can see that water is acting as all three. It is producing hydrogen. It is also accepting a proton at the same time, and it's also accepting an electron. So the answer would be all of the above. The ones below would be examples of aqueous solution questions. So the first question, number 6, what is the molarity of an HCl solution which contains 4 moles of HCl and 5 liters of water? So molarity is mole over liter. So this question is actually very straightforward because all you do is 4 moles divided by 5 liters, it's 0.8. So 6 would be B. And then number 10 would be a bit more complex. Not really, but it's a bit more complex than number 6. How many grams of NaCl are dissolved in 2.5 liters of a 0.7 mole NaCl solution? All you have to do is convert NaCl to grams. So you need to look at the periodic table, which was on the previous slide. Let me see if I can, there we go. So Na is 33 about, Cl is 35.45, so about 58.45. Multiply by that 0.7, you'll get about 40, and then multiply by that 2.5, you get D 102 grams. So these questions here on the slide are a bit more basic. They're not really on the advanced side of the test, but these are the kind of stuff we're going to ask you on tryouts. We're not going to be too advanced either. These would be like level 1 or 2 questions. On this following slide, we have, this is an example, actually a screenshot of this from a test, of an example of some questions the test would ask based on those labs or tasks you do in Chem Lab. So here it's kind of cut off on the top, but you can see that there's some procedures they were giving this participant. They're asking them to do the lab here, and then here is the data that the participant has acquired. And then A is asking the molarity of that compound in the vinegar sample, and so the answer would be based off of the data they got in the lab. So this is kind of what you can expect in the lab or task portion of Chem Lab. And I think that's all I have to say for Chem Lab. Is Taha here? If you would like, I know he did Chem Lab. If he's here, would you like to say anything or add on to anything? Okay, I'm not sure if he's here, but yeah, that's all I have to say for Chem Lab. So if you have any questions, please feel free to put in the questions in the chat. And then next we have forensics. Alice?
Okay, so for forensics, could you go on to the next slide, please?
Yes.
Okay, so for forensics, it's an event where you're given like a scenario and some possible suspects. I remember when I did this at Rice, I had about like 4 to 5 suspects, and you basically run tests in a lab environment to solve a crime. So for event details, first of all, you could have a cheat sheet with all the information that you think you might need for this event. And then you could also bring 2 calculators of any type with you for this event. And then please remember that time will not be used for scoring. So please don't like be in a hurry, or please don't feel like you need to be rushed when someone else turn in their packet or something, because time will not be used to to break ties in this case. And ties will be broken by the analysis of the crime scene. So I recommend you to spend at least 20 minutes on the analysis when you are doing this event. And then 10% penalty will be given if your lab area is not cleaned up. So yeah, that's basically it for the event details. Could you run to the next one? So for tryouts, you would need to know and identify crime scene physical evidence. That would be like DNA, fingerprints, or blood types. And then you would also have to identify polymers. That would be identifying maybe plastics and fiber or hair. And I'll show you a video on the next slide to kind of just tell you how you could identify those. And then you would also have to know chemical substances, like for sodium acetate, they might ask you to draw a diagram, or you need to know the formulas for it. And then you also have to know how to write an analysis at the end. So make sure you kind of research a little bit, read some samples or test answers online about this one. And you would also have to know how to properly use the lab equipment. So you could find this on the Scioli website. I think there's a lab equipment a recommendation list, and then you could go through the list, see which lab equipments you've never heard of or never used before, and please just research it online and then see if there's any videos that talk about these. And then please make sure you know the lab safety procedures. On the pictures on the right, you can see that long hair needs to be tied back, and then there are some kind of chemical solutions you might need to know. And yeah, and then on the next picture, you can see they have a packet with fingerprints on it. So that's the most commonly asked question for this event. So yeah. And then for the next slide, there are some videos. The first one, it demonstrates a fiber burn test.
Okay, so that was a fiber burn test. And then comparing fingerprints.
Mhm.
Oh. 1 second.
Okay. That video basically tells you how you could recognize or just how you could like, compare the 8 fingerprint types.
Sorry, it's taking a while to load.
Okay. On tournament day, I don't think you have to light the candle like by yourself. I think the supervisor will provide you a lighted candle with the flame on it. So that shouldn't be like a worry or a concern.
Open the basics. Before we get into comparing fingerprints, we need to define a few terms. The most basic formation in the fingerprint is the ridge. These are the black lines that form the patterns. The core of a fingerprint, right here in the center, is the innermost recurve at the center of the pattern. This ridge flows up, recurves right in the middle, and flows back down right here in the middle of the pattern. A delta is this type of feature where 3 areas converge into a triangle-type shape. You can see right here is the center of this delta. The 3 basic fingerprint patterns are the arch, the loop, and the whorl. The ridges in an arch pattern start on one side of the finger, rise in the middle, and exit out the opposite side. There are usually no chords or deltas in an arch. The ridges in a loop pattern start on one side of the finger, loop in the middle, and exit on the same side they started. There's usually one chord right here and one delta in the loop pattern. The loop can face to the left like this one does, or to the right like this one. The ridges in a whorl pattern form a generally round shape. There are usually 2 chords, one facing up and one facing down, and 2 deltas, one on the left and one on the right. Looking closer at a fingerprint, you can see that occasionally the ridges will start and stop as they flow through the pattern. This ridge right here flows upwards and stops right here, while the other ridges on either side converge to fill the space. This is a ridge ending. A single ridge will occasionally split into two ridges. This ridge flows up and splits into two ridges at this point. This is a bifurcation. A dot is this feature where the ridge starts and stops over a short distance, making the ridge approximately only as long as it is wide. When comparing fingerprints, you usually use a magnifier and a pair of sharp pointers to keep track of things. The magnifier is like a large jeweler's loop. The pointers can be almost anything that's thin at one end, like a pen, a paperclip, or an engraving tool. On the other hand, you can use a scanner to get the fingerprints onto the computer screen and use Photoshop to mark the point.
Okay. So that was how to compare fingerprints. And then,
like when studying fingerprints, okay.
No,
go ahead. So when studying fingerprints, don't just like stare at the picture and try to find some like features. Try to look up the ways you could study them, like the proper ways you could study them, because that will make it so much easier. And this video shows you how you could identify polymers.
my computer is so slow.
Okay.
So we're going to be set out over here. And we're going to set it up just like we have on our chart here. So right here, we're going to here is our 46% ethyl alcohol. We're going to put that right here. Notice how I have a different kind of bed each one of my substances is separate out.
Okay. So basically, for this one, you have like a chart, and then you put all those solutions into each kind of like block, and then for each plastic, you put it in the first kind of like a block kind of thing. If in that, and then they'll show you that, oh, if it sinks, is this solution, is this plastic. But if it doesn't, if it flows, then you go on to the next step, which is putting the same plastic in the next solution. And then if it sinks, then it might be that type of plastic. If it doesn't, you go on and then you follow the chart to figure out which type of plastic that is. I'm pretty sure the charts could be found online or like on the Sayoli website page, and you guys can look it up for like a few minutes and do that. Yeah.
Hey, is that all, Alice?
Mm-hmm.
Okay, so I know those videos were choppy, I'm sorry about that, but forensics, you are going to need to do those, you are going to have to use some chemistry in order to solve the problems that you need to use in order to solve a crime in real life, so like the fingerprints or the polymers. You do need some chemistry knowledge. So category 3 is a chemistry-oriented category. That's why we put those two events together. So now let's go to category 6, starting with write-a-do-it. So instead of giving you guys a definition of write it, do it, I'm going to explain it this way. So take a look at this model here. How would you explain how to build this model? Okay, think about it. Like, how would you, if you needed someone to build this model, how would you write the instructions for it? Okay, or if you're given these instructions, how would you go about building that same model? So this is exactly what Write It Do It is. Write It Do It is a two-partner event in which one partner is called the writer and what partner is called the doer. The writer is the one doing the writing. So they are given a model at the tournament and they need to write instructions for their partner on how to build this model. And you're given a limited amount of time to do that. So it's pretty difficult, honestly. And then the doer is the one who has to read the writer's instructions, and then they have to build that same model. They're given the materials at the tournament. They have to build that model, and they also are limited. They're time limited. And also, the faster the doer is able to build a model, the more points you get. And so for Write It, Do It, your goal is to be able to really sync with your partner and the writer needs to be able to write thoroughly enough that the doer can build that model at the shortest amount of time possible, as accurate as possible. And Write It, Do It, I know I said this in the introduction presentation in July, but Write It, Do It, it doesn't seem like a science event at first, but it is. Write It, Do It, basically, okay, actually, wait, back up. If you guys have taken psychology yet, you'll know that an operational definition is like a term scientists use in the real world, in which every scientist has to like define their variables thoroughly, objectively, so that another scientist around the globe can replicate the same experiment. And so scientists all around the world, whenever they're doing this experiment, they have to refer to these operational definitions in order to replicate the experiment. That's the whole point. So Write It, Do It tests you as a potential scientist on how well you can make that operational definition as a writer, and then how well you can replicate an experiment as a doer. And so Write It, Do It, really, if you want to pursue this event, you just need to be able to know your partner well, and you need to do a lot of practice, because I've actually done this event since freshman year, and really what I can tell you is that know your partner and practice. That's pretty much my advice for you. But let's go to tryouts now. What do you need to know for tryouts for Write It, Do It? So first of all, you need to know what the event is, which I covered just now, how many people participate in it. I also just covered what you're expected to do in the event and how you are scored and what the goal is and how you achieve the highest rank. Pay particular attention to how you're scored and how you achieve the highest rank. On the rulebook, it explains how you're scored in Write It, Do It. There are certain points given for how accurate you are, how fast you are. So just be familiar with that, because we might test you on that. Also, you need to know how you would effectively describe a model in an instructional manner. And on the test, we may do this by giving you guys a picture of a model, like a model, right? And then you have to describe that model or be the writer and write out instructions on how to build a model. So this way we can test you on how well a potential writer you could be for this event. And then you also need to know how you would effectively build a model based on given instructions. And because we don't have tangible objects for you, right, we can't make you build in front of us. Instead, we might ask you to draw or sketch out a model while we give you guys instructions on the test for that. I've also, if you looked at the resource packet, included a table with key terms that you would need to know for Write It, Do It. And these key terms are basically some references you should keep in mind as a writer. These are some key terms you should use when you're writing your instructions. For example, one of my key terms I put on the table is a clock. And you might be wondering, well, what does a clock have to do with this? Well, a clock is actually a very important and crucial reference you need to know as a writer, because let's say I'm given a plate and there's a model on the plate and I need my partner to put a pin like on the top right position. I can't really say, hey, put the pin on the top right position. Like my partner's gonna be confused in like where on the top right, which like how much beyond the corner. Instead, you can use a clock reference. You can tell your partner, hey, the plate is a clock, put the pin at the 1 o'clock position. So now as a doer, I know, okay, right here, I'm going to put my pin. So these are some helpful references. I've included a table for that. And you need to know these references as a writer and as a doer, because you need to know what the writer is trying to say. So on the tryouts test, we might ask you to mix and match the key terms. We might ask you to explain the key terms or apply the key terms, stuff like that. Most of them are self-explanatory, so if you read through them, you'll be okay. Also, know how to solve a potential situation or problem during your tournament. And I say this because Write to Do It, and Write to Do It specifically, there are a lot of problems you can encounter, and they come all the time. One of the biggest problems would be, I don't understand my partner's instructions, what do I do? And most people will just keep rereading the instructions because they think you can't move on before doing that step. But that's not how you should approach that problem. And we've listed, I think, 3 problems in the resource packets you guys should be familiar with and how to solve them. So be prepared to be tested on that as well. And keep them in mind if you do Write to Do It during the year, these problems and how to react to them. Because sometimes when our adrenaline is kicking, we react pretty poorly. How do you practice Write to Do It, you might be wondering too, because this isn't a study event and this also isn't a build event, right? It's kind of one of those special events. Here I've actually screenshotted my computer from earlier this morning. All I did was typed in Write to Do It practice examples. I went to Google Images and a bunch of models popped up. This is how you practice at home during COVID-19. Just search up these models, right? And you get all these models online. Grab your phone, put a timer, and start writing. Or if you want to practice being the doer, maybe get your sibling to write about a model and then build that model at home with your own stuff at home. So these are some ways you can practice Write to Do It. I don't know if it's going to happen during this year because of COVID, but if we are allowed to go in person, these are some tips you can use. And again, practice with your partner, like go during 2.5 or after school, stuff like that. Is Shreya here? I know you did Write to Do It with me for a long time. If you want to add anything, would you like to add anything? Is she here? Okay. Yeah.
Guys, can you hear us?
I'm sorry. Can anyone hear?
Yes.
My mic is kind of. Oh, okay, cool. You pretty much explained it all, but I'd say Write to Do It is a pretty chill event. So if you're looking for something that's kind of low stress, you should do this one. And if you're good at describing things, and if you're a fast writer, I'd recommend doing it. It's not too like technical science, like classwork kind of stuff. So yeah, it's more of a fun event. Yeah, if anybody has any specific questions, I can answer it, but I feel like you explained it all.
All right, thanks, Shreya. And yeah, also one thing I want to say, this is category 6, right? So category 6 is going to be filled with events that are more partner oriented. So Write to Do It is one of those where, you know, me and Shreya had to do a lot of partner work together. We had to practice and get to know one another. So keep that in mind as we explain the events in this category. Okay, and then event number 4, Codebusters. Nadia?
Okay, so really go to the next slide, please. Okay, so in Codebusters, it's basically you're given a message and you need to encrypt it, or you're given an encrypted message and you have to decrypt it. So it's just basically coded. It's just like code language, kind of. Like you want to send a message from one place to another, but you don't want the middle person to find out the message. So that's why you're using this coded format so that the other person and the middle person don't find out what you're trying to say about what you're trying to say to the person at the other end. So some even details would be you get 15 minutes, and for you have a timed question. The very first one is a timed question, and if you finish if you finish before 10 minutes, you get bonus points depending on how many minutes you're left with. And then calculator, you can bring as many calculators as you want. It doesn't really matter, but the thing is, it needs to be for functional. If you bring anything like a scientific one, or like the one we use at school, TICX2, or yeah, you cannot use that. They won't let you use that. You're gonna take it away. And then
Some of the ciphers you need to know are Caesar cipher, which is basically just you have the alphabet and you're just moving the alphabet forward, the letters forward. So in the next slide or the one after that, I'll have a picture of it. You can see an example. And then there are aristocrat and patristocrats. Those are more of like puzzles. So you have these are just normal messages. They're coded for you and you have to like guess what it could be looking at. Okay, there is only one letter here, so this must be A. Okay, there are two letters here, this must be is. So like it's like a puzzle and you need to be fast with it. So I would say aristocrat and patristocrat and xenocrat, which is a Spanish aristocrat kind of cipher. So xenocrat, aristocrat, and patristocrat are of the same type. It's just that xenocrat is in Spanish. So if you can crack these three codes very fast, and one of your other teammates just know how to do the Caesar, Advent, Veneer, just in a split of a second, I mean, within like 2 or 3 minutes, then you can for sure place in an invitational region outside states. Okay, then you have Advent cipher. It's basically you have a formula, you have it in the packet, you just plug in A value and B value and solve for it. Linear cipher, again, it's like a shift kind of thing, just like Caesar. And you also have a table, a chart, and you just align the alphabets. And you'll also see the table and an example in the next slide. And then Baconian cipher is all about binary. You, in comp sci, you must have learned binary system, binary numbers. So this is one event you can use the knowledge here. And then I just talked about xenocrypt. And then Hill cipher is when you have matrices and you have to multiply those matrices. I just want to mention that this is not like the matrices we learned in Algebra 2. It's completely different than that. And then Pollux and Morbid cipher, this got added last year, so this is a very new one. And this is mainly dependent on Morse code. So yes, you'll see a chart. Like this is not going to be on your trials, but you'll see it in invitationals and regions. Okay, so the format of the test. So you have easy questions, medium questions, and then hard ones, and then very hard ones. So the very hard ones are usually xenocrypt, the Spanish one, and then patristocrats. So yes, so if you know how to solve them, you're guaranteed winning. And then it's always helpful, as I said, to know Spanish because that xenocrypt cipher carries most of the points. And another thing I would say is for this event, it is really, really important that you really work well with your partners. Just like Angelica said, provided do it, you need to know how to communicate with your partner. Because your partners in Codebusters, they know what you're good at. So while they're working on something, they know you're better than the person at solving that cipher. So he can just, or he or she can just pass it to you and you can just do it immediately. So it's all about bonding and figuring out which strategy you can use. And you also have, we might possibly ask a question where we ask you, okay, come up with a strategy. What is a strategy you would use? So one example is provided in the research packet, so just check it out. Angelica, next slide. Okay, so what do I need to know for the trials? So of course, as I just said, a strategy, just come up with your own strategy. You have 3 people participating in this event. So make sure you know what kind of strategy you can use, who works on the timed portion, who works, or do we all work on the time together? Do we split? Just figure it out and think about it, and you might be tested on it on the trials. Then know the type of calculator to use. I already mentioned it. And then Caesar cipher. You need to know how to encrypt and decrypt a Caesar cipher. So if you look at the picture on the top left corner, it says a relationship is based on ... So that is an example of Caesar cipher. I didn't put the other table. You'll find it in the research packet, but it's clearly described there, so I wouldn't want to go in depth. So just know encryption and decryption of it. And then a fin cipher, you need to know encryption and decryption. So there are 2 different formulas, one for encryption and one for decryption. So just be able to plug the A and B value in it and just be able to solve it. the catch here is that in order for you to decrypt, you need to know the inverse of modulus. So the concept is not as simple like doing modulus itself. The inverse is pretty complicated. So I would say you just find the table online and just memorize the inverses. It's not that big of a deal. You can just split it among your partners, so you should be fine. Then linear cipher, it's a very simple one. You'll find it in the research packet, the table and everything. And here is a picture of it. So you're given a keyword and you keep on repeating the keyword, and then you align it with the other letter. You see the encoded letter, and you use the keyword letter, and then you align it in the table. So once you look at the table and look through the videos I posted there, you'll be able to figure it out. Then Hill cipher, encryption only, just solving matrices. You'll see a picture of it in the next slide. And then aristocrats and aristocrats. These two are almost the same thing. The only difference is that in aristocrats, they take away the spaces. So for example, you have a line, you have a sentence saying, I like to play basketball. So in an aristocrat, you will have the spaces, like I will be decoded as A, and then is I like will be decoded in other letters. You're gonna have spaces between them. So you can like easily figure out what this message could be. But in aristocrats, you're gonna take away those spaces. So I like to play basketball will not have spaces. It's gonna be all together. So that's what makes aristocrats a bit challenging. So right after Xenocrypt cipher, aristocrats is the hardest one. So yes. Would you look at the next one? Okay, so one of them, the one with 120 points, that is a linear cipher. It's like the aligning thing. Then the one below that is the matrix. We need to know how to multiply. It's all doing multiplication and being able knowing how to do matrices. In the research packet, I thoroughly put a picture there which shows how you multiply matrices. So if you look through the packet, you're gonna be fine. And then a fin cipher, as I said, you have a formula and you just plug in the A and B value, and yes, there you go. And for aristocrats here, as I said, they take away the spaces. The one, like, look at the one with 250 points, they take away the spaces. So you cannot, it's like, it makes it a bit complicated. And then in aristocrat, the one below that, that is like the same thing, but it has spaces between them. So you see, you can easily like kind of figure it out, I am still blah, 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 blah. So yes, that's it for Codebusters, I would say, and just know how to work well with your partner.
Okay, experimental design, Alex.
Mm-hmm. Next slide, please. All right, so experimental design is explained really well in this like meme Maria sent it to me yesterday. So basically, you have to design, conduct, and report findings of an experiment, like what the meme says, right? So they give you a task that says, like, do plants sneeze? And then you have to come up with a hypothesis, independent, dependent variables, all that stuff. And for this one, it says plants probably sneeze. And then you need to use at least 2 items that the supervisor provides. And then, for example, here, it uses feathers and pepper. So that's to run the experiment. And then you have to come up with a conclusion and you analyze this experiment. And the conclusion for this one would be plants don't sneeze. In like real life, you would have a prompt or like assign a question, like the picture on the right, which is rotational inertia. So basically they will kind of like provide a definition for you, and then they would assign a task that says like, design a conduct experiment on the topic of rotational inertia. And then it tells you that you have to use at least 2 of the items provided. On the picture on the left shows you like the similar or exact environment you'll be working in. You'll sit with your team, and then you need to bring calculators, rulers, or like some sort of like timing tools to help you with this experiment. Yeah, next slide, please. Event details. So this event is going to be divided into 2 parts. for the first part, it'll be about 20 minutes, and then they will give you the first packet that allows you to design and conduct the experiment, like the one I just showed in the previous slide. And then for this part, you will be answering questions like the hypothesis, which is what the picture is showing, and then you could look up templates or how to write them or how to answer them online. And part 2 will be analysis and report. So that's basically when you are drawing graphs or just reporting and analyzing your experiment. And then again, you must use at least 2 materials. So for this event, I would say that get to know your partners really well, because this event has to be a team up to 3. So y'all should practice a lot on this, and a lot of practice tests could be found on the CLE website. Any team that does not follow the cleanup procedure, their final score will be multiplied by 0.95. And so just please read over the rubric again and go over the rubric on the next page that follows the rules for experimental design. And that basically tells you everything you need to know for this event. And then any team that did not address the assigned question or the answer or something is off topic, the final score will be multiplied by 0.75. And then if a team did not collect data based on the experiment they conducted, their final score will be multiplied by 0.25. So please make sure you know those rules, and then just keep it in mind that you should be following the rules on the CLE rubric, and again, go over the rubric. It's super important. And I also linked 3 video links on the review packet, and then those videos basically tells you strategies or just big rubric review. So please make sure you go those videos. And yeah, for the tryouts, you will need to know vocabulary again, like hypothesis, independent, dependent variables. But you don't you're not only studying its definition, you're also applying it. You're answering questions about how to write a hypothesis, how to identify independent, dependent variables. And there are tons of vocabulary words you have to know. So please make sure you look over the Quizlets in the packet. And for tryouts, you would also have to know the general rules of this event, the rubric, and like Amanda and Madia said, it's really important that you know your partner and how you guys are gonna work on tournament day. So please make sure you come up with some strategies on how you could effectively work with a team of 3. For example, whenever you get the part 1 packet, you have 20 minutes to run or design this experiment thing. And how would you able to use your time wisely? Are you guys gonna split the packet, or are you guys gonna assign each person with different tasks? One person records everything and the other person designs it and runs it. And I think it's really important that you plan this out before you actually do this event. And the last thing I would say, just practice a lot. I have linked a few practice tests in the packet as well, so please make sure you look over them. And next slide, please. This is some of the parts on the rubric that I want to talk about. First one would be the graph. Graph is worth of 12 points. And then for this one, I want to talk about that, just an example, you could see that the requirements, the graph needs to be titled and labeled. So make sure you have a title, and then you need to have units and a scale, which would be the legend. And then if you don't know what sig figs are, you should definitely look that up, because that 12 points shouldn't be lose, you know what I mean? It's pretty easy to get those 12 points, so make sure you look over every part of the rubric and make sure that you understand every part of it. And the last picture on the right just shows you a template of how you could state the problem. It's a template that tells you how you could include the independent variable and the dependent variable in a question. So I think Shreya did this event before. Shreya, do you have anything to add on to?
No, not really. But
Okay.
You got the main points. It's really important to like look over the rubric and actually know what you're being graded on, because some things aren't as self-explanatory as it seems. And you should go into the Scioli wiki because it explains a lot of like the technical things about how they grade you. And before you like walk into experimental design, you should probably have a good idea about like who's gonna do what, and you need to definitely split it up because you won't have enough time.
Yes.
The main part of experimental design is like thinking of the experiment when they just give you a bunch of random materials. So if you and your partners like before the event, like in terms of practice, find like random materials that people have been given for experimental design and like kind of think of experiments, that would probably be helpful because like thinking of the experiment takes a lot of time, and it's because writing the lab report is the same every time because it's just standard procedure and things like that. So if you're really good and you know all the parts of the lab report, then your main like hurdle is going to be just like thinking of the experiment, and then after that is just technical stuff.
Okay. Thank you. So I would recommend at least using 5 minutes to just stare, not really like staring at the topic, but think about it and try to plan it out. And yeah.
All right, do you guys have any questions for us in the chat? I can't see it because I'm recording, but it's drawing. Okay. Are there any questions?
Okay. I'm joking. Someone asked something. Are we allowed to use calculators on the tryouts? For our Codebusters, yes. Without a calculator, you cannot solve many of the math-related problems like in Cipher. So yes, but make sure it is a 4-function one. So yeah, that's the only restriction there. Anything else?
I don't think you would need a calculator for experimental design and forensics, but if you do, yeah, we'll allow you to use it for the tryouts. But I don't think there will be questions that
you're allowed a calculator for experimental design because there's a statistics part.
Yeah, but I don't think we're gonna like ask those kind of questions on the tryouts test. Definitely for the events, you would definitely need to use calculators. Otherwise, you will be like in a super disadvantage. So yeah. Do you have anything else to add on to, Angelica?
For Chem Lab?
Yeah.
I think that's all. Is there anything anyone would like to ask about it? No? Okay, and then feel free to text us in the Discord server if you have any questions. We'll get to you readily. Also, apologies for the pen marks. I'm not sure how that's happening, but thank you, and please keep in touch with us, and we're looking forward to seeing you guys throughout this week.
Bye.
Bye.